So, I'm going to be talking today about building an event experience with pgvector Similarity Search. My name is Valerie Woolard. I'm a principal member of technical staff on the Heroku data team. And pgvector is an awesome new feature that we've added to Heroku Postgres that will help enable you to use AI-enabled applications on Heroku. So let's get started. Remember, Salesforce is a publicly traded company, so please don't make purchase decisions based on products that aren't publicly available. So let's go into the agenda. First, I'm going to give you an introduction to Heroku, what we do, how we might be useful to you, and then we're going to talk more specifically about what pgvector and embeddings are helpful for. We're going to go through a practical example, and then I'm going to give you some options for learning more and exploring the content of this presentation in more depth if you're interested. So let's start off with what is Heroku? So Heroku is a platform as a service that allows you to abstract away a lot of the maybe annoying things about running infrastructure. It's built by and for developers. We provide managed and scalable infrastructure so you can focus on development instead of operations. We want to make it easy for you to deploy your code and iterate quickly. As you can see in this real-time video where we'll be showing an example of deploying code to Heroku. It's very fast. And that's the idea. We want you to be able to focus on the things that you care about. We're hoping to enable you to build apps and build solutions without having to worry too much about all of the infrastructure behind that. We want to make that super easy for you. We want to take the configuration and the DevOps layer away and just let you focus on building really great products. And as you can see in this example, we are almost done with pushing some brand new code to Heroku. And so every time you can imagine when you are changing your app or wanting to launch a new change, it can be that fast. Now let's talk about Heroku Postgres. Heroku Postgres is a managed Postgres database product by Heroku Heroku Data Services team. That's my team. You attach this Postgres database to your Heroku apps, and we handle patching, maintenance, and even provide point-in-time recovery if something bad happens. We provide support for many Postgres extensions, including PostGIS for geospatial data, and pgvector, which we'll be talking about a lot more today, for vector data. So what is pgvector? It's a managed vector database for high dimensional similarity searches. So vector data is something that's really taken off a lot recently because it enables you to use AI embeddings. And with pgvector, you can add vector data types to your existing Postgres data. And this allows data to live in a normal relational database alongside the rest of your data. It's particularly useful if you're building AI-enabled applications because vector data is used for storing the output, also called embeddings, of passing data through AI models. So what are vector data types? You've probably worked with these before if you've done linear algebra or maybe physics. They can be expressed as a list of numbers, which you can think of as a quantity in n-dimensional space. And the big idea here, without getting into the too mathematical part of it, is that these are going to look like really long lists of numbers, and semantically similar things represented by these embeddings should be close to each other in vector space. So let's go through an illustration of how that might look. So here we've got some vector embeddings of different words mapped out in a two-dimensional vector space for visualization purposes, but a vector is actually going to be many more dimensions. So in this example, we've got the words man, woman, king, and queen. And we can see that they're both like pretty close in vector space. And they're also, the two pairs are about the same distance away from each other. So man is about the same distance from woman as king is from queen, because those pairs of words relate to each other in the same way. So to think about how data goes from being just normal data to a vector, this is kind of the flow chart. So let's say you've got your data in normal human language, like session descriptions or article texts. You're going to pass that data through a model like Hugging Face's sentence transformers, or one of OpenAI embedding models, or even one that you train yourself. And that model is going to give you back an embedding. And that embedding is a vector generated by the model. It'll probably output a vector of some fixed length, whether that's 100 or 384. And this is the value that you're going to actually be saving into your database and using with pgvector. And we've been talking about this really abstractly, so let's go through a more concrete example to give you hopefully a more solid idea of how this can be really powerfully applied. So, for example, you have an event, maybe a conference or something along those lines. You have sessions with names and descriptions and lots of attendees who aren't sure how best to use their time. You could have attendees fill out a registration form and ask them about their interests or what they're hoping to learn. From that information, you could generate embeddings for both the sessions and the entrance forms and match attendees with sessions most relevant to them. Let's walk through some code snippets of how you might do this. Okay, so for starters, you need a Heroku app with a Postgres database. Here we've got the Heroku add-ons create command to create your database. Once you have that database, you're going to want to connect to it and enable pgvector. In this example, you just run create extension vector, and then from then on, you are going to have the vector data type available to you in your database. Now you can create a table containing a vector data type. So in this case, I'm creating a talks table. And the most relevant parts of this table creation are going to be this very bottom line, the embedding. That's where our vector data is going to live in our database. And the title and description. Those are the fields that I'm going to be using to pass through the model to actually create the vector. Similarly, I'm creating my attendees table. This contains some metadata about attendees, first name, last name, email. But most importantly, again, we're going to have that vector embedding column and the interests column, which is going to be what we use to create the embedding. I've provided raw SQL code here to illustrate, but your app framework that you're using probably has a way to do this with a Postgres client. So it should be pretty trivial to look up however to do this in the language that you're most comfortable with. So now we've got our database infrastructure set up. We've got our tables created, and we want to actually put the data in those tables. So here's how we would load the data and embeddings. This example, again, is using Hugging Face's sentence transformers model in Ruby with the pgSQL and Hugging Face and pgvector gems. But there are pretty equivalent tools that you could use in, say, Python or other languages to do the same thing. So here, I'm creating a client, a Hugging Face client, with my Hugging Face API token, which you can actually get for free. And I'm creating a talk in my database. So I've got that talk.new, I've got a talk title, I've got a talk description that's coming from my program or whatever it is. And then to generate that talk embedding, I'm going to send the talk title and description through that Hugging Face inference API, and it's going to give me back an embedding. I want to save that to my database, so that talk save changes is going to save everything about that talk to my database. And now I have that embedding available to me to run other sorts of queries on. Once I have all of my talks in my database, I want to add the attendees. So for example, I've got Cody. His interests are developing apps for Slack and learning about the latest techniques in AI. Just like with the talks, I'm going to get the embedding of his interests through the Hugging Face API, and then save all of that to my database. And once I've done this for all of my talks, all of my attendees, I can query for similar sessions. So for example, if I've got Cody and I want to find the talks closest to Cody's interests, I can run this nearest neighbors query to find the embedding that is closest to Cody's embedding with a Euclidean distance measure and limit to 5. So in plain English, this will give me the 5 most similar talks to Cody's interests. You'll notice here I use the Euclidean distance measure. pgvector supports Euclidean cosine and inner product distance measures. Which one works best is going to depend a lot on your data and what it looks like. I encourage reading some more about that or even just experimenting with your data and seeing which one tends to get you the best results. So given just this data, how might you use this? You could display recommended talks on a web portal for your attendees. You could email attendees with a personalized list of the most relevant talks to them. You could build a schedule for each attendee with the most interesting talk to them for each time slot. And you could connect attendees with similar interests. So this example was mainly meant to inspire you and think about how you might use this in the work that you're doing. How could you use Similarity Search in your work? You could use it to make better semantic matching for queries. You could use it to run image similarity searches. You could use it to recommend similar articles or products to your users. And these are just a few ideas to get you thinking. I encourage you to think more about what semantic searching can give in your specific use case. Now we've talked about vector embeddings and how you create them, but another important piece of this puzzle is how you create them. What model do you use? How do you choose a model? How do you choose what data to include? These are all really big questions that I'm not going to be able to cover in depth in this talk, but some things that you might want to think about is what data are you going to include? What is going to give the most relevant context to that AI model for the kind of matching and similarities that you're interested in? So for example, in the code snippets that I wrote, I didn't include the talk time or the talk location in the data that I embedded, that I sent to my AI model. And that was because I didn't feel that it was relevant for what I was doing in matching attendees' interests to the talks that they wanted to attend. The next thing to think about is what model to use. And in that, you'll want to think about how was that model created? What training data was used to create the model? And in general, the training data that is closest to the data that you are using is going to give you the best results. So for example, if I wanted to build an application that dealt with a lot of really technical language, or maybe domain specific, maybe medical, or other really topic specific language, a model that was trained on a more general corpus like Yahoo Answers or Wikipedia might not give me the best results compared to something that is trained on data specific to that domain. So thinking about what training data was used to create the model and how relevant that data is to my use case is going to probably help you out a lot in selecting the most appropriate model for your use case. And hopefully this talk has given you some appetite to learn a little bit more about this and how you can use it. The next places I would point you to, if you're interested in learning more, are the pgvector docs and the pgvector posts that we've created on the Heroku blog, the Hugging Face docs, and the Trailhead module to drive AI within your organization. And that's all. Thank you.